Welcome back, everybody. This is going to be our Algebra 2 quadratic functions lesson number 10, equation of circles home review part 4. And in this one, we're going to be solving system equations graphically. And so hopefully this will be helpful in being able to graph circles, especially with circles. We find graphing probably good to have a compass, those things that make circles in this case, right? All right, so and again, if you find this video helpful, if you're stuck on the question and you're like watching this and going, oh, that's how it's done, please give this video a like if you learned how to do what the question is asking for from the video. And leave a question or comment, any words of encouragement, or if you think that maybe you could done a little bit better, more effectively, I would love to hear that as well too, okay? So here we go, question number 6. Solve the following system of equations graphically. All right, so the first thing is that our center for this circle is going to be 0, 0. We know that for a fact. And r squared equals 25. So the radius of a circle is 5. So what you're going to do in this case is take out a compass. All right. Now I have something that helps generate circles for me. So what I do is I put my center, in this case, at needle point, which should be at well, actually maybe I'll use compass like you guys should do. Okay. I'll bring up my compass here. All right. It's a big compass. All right, so here we go. So the center will be at 0, 0. That's my needle point. And let me change this color to a color of maybe like red. And opening up this compass to 5 units. Okay, 5 units in this case. So it's about 5 here, all right? All right, so, and then once you open 5 units out, you're just going to draw a circle. Okay. All right, there you go. Let me just get rid of my compass here. All right. So that's my circle, all right? So middle point on the center, open up for the length of radius, and make a circle here. Now, I next want to figure out the equation of the graph in this case, y equals 5 minus x squared. Well, I'm going to make a table here. And so, now the nice thing is this, my b value is 0. So if I'm axis symmetry, okay, x equals neg b over 2a, my b value is 0 over 2 times neg 1, which is just going to be 0. So I make my 7 values here. I make 7. You can do more. Less is kind of tough though. So 0 for x will be my middle value, and I know my value here for y must be 5. And then I plug in values for 1, 2, and 3. X is 1. 5 minus 1 squared is going to be 5 minus 1, or 4. X is 2. 5 minus 2 squared is 5 minus 4, which is 1. X is 3. 5 minus 3 squared is 9, so 5 minus 9 is neg 4. Oops, sorry. I put that in the wrong place. Let me just erase that. So when x equals 3, a y value is neg 4. Okay? And the nice thing here after I found my axis symmetry is that the next 2 units above or less than 0 will have the same y values. That's one of the properties of parabola. So let's kind of plot these points here. So at x equals 0, y equals 5. Oh, look at that. I already found 1 point. All right. When x equals 1, y equals, oops. When x equals 1, let me erase this thing here. It's the tough part about having this here. I gotta be careful not to drag the pen. So x equals 1, y is equal to 4. Okay, that's 1 point there. X equals neg 1, y equals 4. X equals 2, y equals 1. X equals neg 2, y equals neg 1. X equals 3, y equals neg 4, and this is the other point intersection. And when x equals neg 3, y equals neg 4. And so we see here that if we graph this now, I'll use yellow. We actually have 3 points of intersection. One here, and one here. our 3 points will be at 0, 5, at 3, -4, and at -3, -4. Now, those are our points, our solutions in this case, okay? But we have to check though, so let's do a check. And so we're going to check both equations. So we begin with the coordinate 0, 5. Does 0 squared plus, in this case, 0 squared plus 5 squared equal 25? 25 equals 25. That's a check. So this is a correct, well, in this case, let's check the other one though. Just because it works for one solution, one equation, doesn't necessarily mean it works for the other one. So does 5 equal to 5 minus 0 squared? 5 equals 5. Yes, that does work out. So yeah, that's one solution there, 0, 5. Our next check will be with -3, -4. Does -3 squared plus -4 squared equal 25? Well, that's going to be 9 plus 16. That's equal to 25. 25 equals 25. That's a check. Now for the other equation. Now right to the left over here. So in this case, does, and again, -4 is a y value. Does that equal to 5 minus -3 squared? We have a table, but just work it out anyway. So -4, does -4 equal to 5 minus +9? -4 equals -4. That's correct. So that's our second coordinate we checked for both. And finally, we're going to check the third one. Our third coordinate was going to be 3, -4. And so does 3 squared plus -4 squared equal to 25? 9 plus 16 equals 25. Yeah, 25 equals 25. That's a check. And does it work out for the other equation? Does -4 equal to 5 minus 3 squared? -4 equals 5 minus 9. Yeah, 5 minus 9 is -4. That's a check. So our solutions in this case will be our 3 coordinates. 0, 5, -3, -4, and 3, -4. And yeah, interesting enough, we can have more than one solution, definitely more than 2 solutions. Actually, in this case, we had 3. We had 3, okay? All right, everybody, I hope this was helpful, all right? And it really helps to have a good compass and all right? But in our next question, in our next video, we'll be solving system equations with circles algebraically, though. But this is the end of our Algebra 2 quadratic functions, lesson number 10, equation circles, homework review, part 4. And again, if you found this helpful, please give it a like, all right? And subscribe to the channel so that you'll be notified when new videos are added to the channel. All right, everybody? Thanks so much for watching. Take care and be safe.